Hi, my name is Timothy All, and this is a video abstract from my paper on P-adic annihilators of real ideal classes. It was Kummer who first noticed that there was an explicit element of the Galois group ring Q adjoin G, where G is the Galois group of Q adjoin zeta P over Q. There's an explicit element in this group ring that annihilates the ideal class group of Q adjoin zeta P. This element now is known as the Stickelberger element for Q adjoin zeta P. So this element has become, and Stickelberger elements in general, they've become very fundamental and useful objects in algebraic number theory, at least as it pertains to abelian number fields. For example, Iwasawa has used Stickelberger elements to construct the P-adic L functions of Leopold and Kubota. And as recently as 2004, Mielescu has used Stickelberger elements in his proof of Catalan's conjecture. They've played an important role in his proof. They're very fundamental and useful objects, and they've been generalized since the days of Kummer to extend to kind of general abelian number fields. Unfortunately, though, if you take one of these Stickelberger elements and you apply them to a real abelian number field, they devolve into multiples of the norm, and so they're not very interesting annihilators at all of the ideal class group. There's no real hope of actually gaining any good information about the ideal class group, if the field that you're interested in is a real abelian field. So the question is then, where are the Stickelberger elements for real abelian number fields? Do we have any hope of getting explicit elements, writing down explicit elements in a group ring that we know will annihilate the ideal class group of a real abelian number field? So this paper answers that question, and it answers it in the affirmative. In this paper, we derive annihilators, explicit annihilators of the ideal class group of a real abelian number field, a la Stickelberger. These annihilators, they wind up living in a group ring with coefficients that are p-adically defined, and so consequently, these annihilators actually annihilate the p parts, or essentially the p parts, of the ideal class groups of real abelian number fields. And we also compute the index of the ideal generated by these annihilators. And the index of the annihilators generated in the appropriate part of the group ring, they wind up being related to, and in many cases equal to, the p part, essentially the p part of the ideal class group, the order of the ideal class group of a real abelian number field. And this is very analogous to the classical situation where the index of the ideal generated by the classical Stickelberger elements in the appropriate part of the group ring there is related to and often equal to the relative class number. So there's a nice analogy to be drawn there as well. So, thank you very much.